All right, back at it. Here's our next example. We've got 24x cubed plus 52x squared plus 8x equals 0. We're trying to solve this equation using factoring. They already got the 0 by itself for us. It appears we're already in standard form. Now we just got to ask ourselves, is there a GCF to take out? And it's a clear and resounding yes, because they all have an x. Okay? They're also all even. My thought is, what's the biggest number that they all divide? So, if you're having trouble figuring that out, just maybe go off to the side and ask yourself, okay, 24, 52, and 8. Do they all divide 8? Because if they all divide 8, you can just take the 8 out. Does this divide 8? Yes. Does this divide 8? Yes. Does this divide 8? No. 8 times 6 is 48. 8 times 7 is 56. So this does not divide 8. So you can't take an 8x out of here. Okay? So then you find the next multiple down that's even, 4. So 24 divided by 4 is 6. 8 divided by 4 is 2. 52 divided by 4, 13. So 4x is the GCF that you can take out of this whole polynomial. So if I divide everybody by 4x, that gives me 6x squared, right? Plus 13x plus 2. So now I got a decent polynomial to deal with, not big numbers anymore. 24 times 8 is going to be a pretty big number. I think it's something like 192. Factors of 192 are not as nice to map out as factors of 12. So let's do the AC method on this. All right, yeah. So what multiplies to give me positive 6 times positive 2 and adds up to give me 13? And this brings us back to the example where it's like, hey, 12 and 1 multiplies to give me 12, adds up to give me 13. So 12 times 1 gives me 12. 12 plus 1 gives me 13. I don't know. It really doesn't matter at this point who you match with whom. I guess I'm going to just take the 12 and put it here, 12x. And it's going to be plus 1x. So the middle polynomial becomes 6x squared plus 12x plus 1x plus 2. Inside the parentheses, I'm going to kind of ditch this 4x for a while, or just put it on the shelf, bring it back at the end. When you group them together, this thing divides 6 and x. If you divide by 6x, you get x. You divide by 6x, you get 2. Now, what happens if you've got two very small terms that don't seem to have a GCF? Well, you can still take out a 1. You can technically say they both will divide 1, so that's going to kind of be our GCF placeholder, because you got to take something out. So we're going to say plus 1. And that will leave you with x plus 2. This divided by 1 is going to give you x plus 2. Your GCFs become one of the binomials. Your x plus 2's make up the other one. And remember, this whole thing equaled 0. So we need to make that happen. And the 4x comes back into play. So make sure when you're solving these equations, your final move has to be the zero product property. Which states that this 4x, that could be 0. Or this 6x plus 1 could be 0. Or this x plus 2 could be 0. So 4 times blank gives you 0. You divide by 4. 0 divided by 4 is 0. There's our first solution, or at least our first potential solution, x equals 0. Here you're going to subtract 1 from both sides, and divide by 6. Remember, this is not negative 6. It is negative 1/6. This one you subtract 2 and you get x equals 0 minus 2, negative 2. So these are 3 potential solutions you get. All right, this number 9 is an interesting equation that I think showed up on your last assignment, at least one very similar to it. Remember, don't just start making up rules when you see something that doesn't quite fit. Just ask yourself, what is the thing I'm supposed to do always? Well, when solving an equation that involves powers just bigger than x, so like x squared, you tend to want to factor things, which means you want to create a zero product property situation. 0 by itself. So in order to get 0 by itself, I can either move the x here or the x squared there. Doesn't matter to me. I will show you that you can move things to the right-hand side if you want to, though. You are perfectly free to do that. It doesn't have to move everything to the left. So 0 now equals 10x squared minus x. In fact, you can now do the symmetric property where you rewrite it where 10x squared minus x is on the left and 0 is on the right. All right, now you ask yourself, is there a greatest common factor between 10x squared and minus x? Yeah, you can take out an x. So by dividing both parts by x, you figure out what the leftovers are. This is just going to be 10x. And a lot of times people will just leave it blank right there. They'll be like, hey, they canceled out. Yeah, 1. They canceled out with division, which gives it 1, which is definitely not the same as addition and subtraction. So now we can go directly to the zero product property. We don't have to do AC method factoring because we don't have a 3-term trinomial. So x is equal to 0 right off the bat, or 10x minus 1 equals 0. Which, quick math, add 1, divide by 10. It's 1/10. Last example, number 11. You know what? I'm gonna shift gears here. 11 looks way too much like number 7 and doesn't give you guys like an actual. It doesn't give you as much variety as I'd like you to see on this video. I'm going with number 10. All right, so this is an interesting one. First of all, get 0 by itself, which I'm going to move the 56x to the left-hand side. I'm going to wedge it in between the square and the constant, ax squared plus bx plus c. Right there. There's my negative 56. So 7x squared minus 56x plus 105 equals 0. Now don't jump into the AC factoring just yet. Take out a GCF if you can. So 7, 56, 105. You just got to ask yourself, do they all divide 7? I know the first two do. Now the last one. What's 105 divided by 7? I believe it's 15. So it's only a 7. It's not a 7x because the 105 doesn't have an x to take out. So if you take out the 7, the leftovers will be 7x squared divided by 7. Negative 56x divided by 7. Yeah. And then 105 divided by 7, which is positive 15. And that whole thing equals 0. Now the AC method shows, remember, the 7 is now out of it to make the AC method factoring easier for us. 1 times 15 is 15. And then negative 8 is our B value. Now this is a minor detail that a lot of times students will miss because they're just not paying attention to positives and negatives. You multiply to get positive, and you're adding up to get a negative number. The only way to make that happen is two negative numbers. So you're thinking to yourself, negative 5 times negative 3 gives me positive 15, adds up to negative 8. So then you split up your negative 8x into, let's see, I'm going to put the negative 5x with the 15 here, and the negative 3x over here with the x squared. Factor by grouping. These two share an x, leaving you with x minus 3. These two, now this is one of those easily overlooked mistakes that students make. You're trying to get x minus 3 in the leftovers. I think we can all see that it divides 5. But if you don't take a negative 5 out, you're going to be left with negative x plus 3. I need x minus 3, which means I have to take the negative out with it. Okay, that's just going to be a mistake that some of you guys, you'll learn the hard way. All right, group together the GCFs. The leftovers are x minus 3. Remember this 7? It's still a part of the factored version of that polynomial. Now when we go to the zero product property, we're looking at this factored polynomial in its relation to 0. It's this whole idea that x minus 3 must be 0, x minus 5 must be 0, and then remember when we said 4x equal to 0 in that previous example? Well, 7 equals 0 is sort of like, what's going on there? Well, that just means that you're not going to get a solution out of taking a constant. You can take a 7x out, and that would give you x equals 0, but just taking a 7 out gives you no, how should we put this? Let's just, I think I'm getting ahead of myself. Let's first show that there are two solutions here. X equals positive 5 and x equals positive 3. Yeah. There is no third solution from this. It's just these two. This is your final answer. All right. So you guys, the six problems I gave you on these YouTube videos, of course you're not going to be responsible for showing me the work there. That'd be like you copying it down from YouTube. That's not necessary. But the other 6, that's your last assignment for remote learning. So good luck on that. Please send me an email if you don't know what you're doing. That's much better than just not attempting. Okay? See you.